Good afternoon, students. Today we will see signals and its classification for the course Signals and Systems. So I am Senthil Kumaran, Assistant Professor ECE Department. I am going to give a in-depth detail about the signals which is available in the system. Signals and how the signals are used in the systems also. What is a signal? Let us see. Signal is a information which is available anywhere in the place. So what are all the possibilities of a signal is, a signal can have a functions with respect to time, or it may be vary with respect to time. So basically a signal is a physical phenomenon that has one or more variables. One more concept of a signal is a time varying quantity. That example may be a electromagnetic signal also. So what is a time varying signal means? It varies with respect to time, or it is a function of time, that's all. So this is called as a time varying. Next, few examples of a signals. So what may be an examples of a signals? I have listed some only few signals. It may be a voltage or a current in an electronic circuit, and if it is in terms of a mechanical, we can say force and a torque, and the position, velocity and acceleration of an object, and flow rate of a liquid or a gas in a chemical process. And even nowadays we are using mobile phones to take our image, videos and recording audio signals. These things are also an example of a signal. Next one. So again, this is a classification of our signals. So this is a broad and basic classification of signals. Here first we will classify the signals based upon the variables and whether it is dependent or independent variables. Next one is our continuous or discrete independent variables. Next one is our continuous or discrete dependent variables, and the next one is continuous time signals and discrete time signals. So the last two, continuous time signals and discrete signals, are the real rulers of the world. What is an example of a continuous time signal is whatever we are speaking, whatever we are listening, whatever the things which is taking place in the world is a pure 100% example of a continuous signal, and we will call that continuous signals also a analog signals. What may be an example of a discrete signal is most probably after taking an analog signal, if it is sampled by some time period, then we will call that as a discrete signals. Next slide. So let us now see the classification of our independent variables. So what is a signal? That it is independent with respect to any variables, then we will call it as a independent. It will have only, for example, one function with respect to an value, then we will call it as a one independent variable signal, and that is called as a one-dimensional signal. So what may be an example of a one-dimensional signal is a audio signal, that's all. Next one is more than one independent variable, that is called as a multi-dimensional signal. So what may be an example of a multi-dimensional signal is our image as well as video. What's the difference between this image and video is so simple. Image is also a photograph, video is also a photograph, but video will have some information about the time, at what time this image should be displayed, like that it will be given. So image is a two-dimensional and video is a three-dimensional signal, that's all. Next slide. Next one is the continuous or discrete independent variables. Here the signals are continuous and it is going to be independent with respect to other values. For example, voltage and current waveforms, these are all independent. It doesn't have any relationship with other values, like that. Next one is a signal with discrete independent variables which is having discrete intervals. What is an example of a discrete interval means? If suppose I am saying from 0 to 10, I will take the data at certain intervals. For example, 11 o'clock, 10 o'clock, 12 o'clock, like that. If we started to take values from certain defined intervals, then we will call it as a discrete. But continuous means it is starting from some time period to time period, all the data will be included. That is the continuous. Next one. Next again is, it is a continuous or a discrete dependent variable. What is a discrete dependent variable is, it depends, its output depends upon one of the past or a future values that may require to do this. So that cases we will call it as a continuous dependent signal. Here also we are having two cases. One is our continuous and another one is our discrete. So here again the continuous is, it is continuously taking data from all the values, but in a discrete we will be taking at certain interval. Any image whatever we are taking, it is a digital dependent, that is a digital image, that's what we are taking. Next one. Finally, this is the practically known names to everyone. There are two basic classifications, analog and digital signals. What is an analog signal is whatever we are communicating in the real world without any help of any devices, electronic devices or any gadgets, we will call it as a analog signals. So our speech, whatever the signal we are viewing through our eye and whatever the signal we are listening through our ear, all these signals will be called as a analog signals, but the same analog signals is converted into a digital discrete and then it is converted into a digital by a process called as a sampling that I am not introducing anywhere here. But anyway, what is a discrete is we will take the data at some discrete intervals, then we will call it as a discrete signal. So nowadays all our mobile phone, everything depends upon its working is depends upon the discrete signals, and finally the discrete signal is stored in the form of a digital signal also. So whatever the audio we are listening with the help of mobile phone, everything is an example of a digital audio. And actually one thing we should know, there is no possibility of a digital image. It can be in the system, but we cannot view or we cannot visualize a digital image because our eye is capable of understanding only and analog signals. So we cannot put any digital signals, right? So again there are some elementary signals. Let us understand what is this is an elementary signal is. Most probably we cannot know or you may not understand what the word I am going to say next. So if such case is there, we cannot analyze what is the process I am going to do. So for that purpose, what we will do is, if we want to design any system, we will put some signals and we will monitor the output. So for this signal, if this is the input, if this is the output, then my system is correct. So to understand the correctness of my system, we will be using the elementary signal. So this basic property is, in an elementary signal, I know what is my property, what are all the possible actions I can do with my signal. So simply we can say I know the properties of a signal. This is the case. So it consists of step signal, impulse signal, ramp, exponential and sinusoidal signals. Next one. So what is a step signal is? It is similar to a staircase step. Simple, that's all. It will have a values from 0 to, it won't have a values from 0 to t, and after that it will have a value. So we can simply define a step signal as u of t. It is a general representation, this u of t. So u of t is equal to 1. That 1 is my amplitude, which is going to be available for a time greater than or equal to 0, and rest of the values it will be 0. So simply if we say from 0 to left side, this value or amplitude of the signal is 0. So from 0 to right hand side or simply a right hand side, the amplitude is going to be 1. So this is the simple concept of a step signal, and we can get a step signal by just doing an integral integration what is available in max. Next is my impulse signal. So the word itself is self-explanatory, impulse. It is going to take place for a short period of time. So here it will occurs only for time t is equal to 0, and rest of the places there won't be any signals available. So this will be, or this is mathematically represented as del of t, which is equal to 1 when time t is equal to 0, and it is 0 when t is not equal to 0. That means it will be available for a fraction of second. This is also called as a delta function. Next, ramp signal. Ramp is so clear, and again it is a name. Ramp means it is going increasing the height linearly. So this is the ramp. So ramp is a standard signal which starts at a value 0 and increases linearly with respect to time. Your mathematical equation y is equal to mx plus c is a perfect example of a ramp signal. So this is represented with the help of a word r of t. So here t varies, or it is a function of r of t is a function of t that is greater than or equal to 0, and it will be 0 below 0. That is left hand side, all my signal values are 0. So it is similar to a linear increase in the value. That's all. This is called as a ramp. Next one is my exponential signal. So this exponential signal has three properties based on its values. Let us see what is an exponential signal is. X of t is equal to a into e power alpha t, where a is my amplitude, that e power alpha t is my value. This case here I am showing is an exponential signal for a real case, and there is a possibility of a complex signal also. So A is my A and alpha are both are real, and A is the amplitude of the signal. So let us split this amplitude of the signal by 3 cases. One is alpha is equal to 0. So when alpha is equal to 0, if we substitute alpha is equal to 0, then our equation becomes e power 0. So at any value of e power 0, we will get a value that is equal to 1. So that's our first graph it shows. So when alpha is equal to 0, my x of t is always 1. This is the first case. Next case 2, alpha is positive. When alpha is positive, the signal x of t is growing exponentially. That means it is increasing exponentially. Next case, when alpha is less than 0, that is negative, the signal is decaying exponentially. So slowly the signal starts to lose its amplitude. So this is the 3 cases of an exponential signal. For now simplicity, I have not included the complex signal for this analysis. Next. So this is going to be a more important signal, sinusoidal signal. That's why I put this in the last slide. So the sinusoidal signal is a periodic signal that swings up and down. This is the most important case. If anything is non-uniform, then we will call it as a aperiodic. Most probably all our sinusoidal signals are periodic signals. So why the sinusoidal signals is most widely used is according to Fourier, right? Who found this Fourier series. A complex sinusoidal signals can be written in terms of simple sine functions, so that simple sine functions are easy to analyze. So sine as well as cosine signals may also be used to analyze our systems. So that's why it is. But basically in our electrical systems, EB also we are having a voltage. That voltage starts from 0 and it goes up to 230 and again bounce back to 0 and it goes to negative and again it goes to 0 also. So that's what a signal starts from 0 and it goes to some values. All our electrical appliances are following or having the sinusoidal signal. So let us see the waveform of the sinusoidal signal. Next. So this is the example of a sinusoidal signal. So it starts from my 0 value and it is going to some higher value and then it comes down and again the cycle repeats. So here the width of the signal, that is T naught marked in the graph, is uniform and that is the cycle. If the T naught value is always same with the amplitude, then we will call that signal as a periodic signal. So the sine signal can be mathematically represented as x of t is equal to a cos omega t plus phi or a sin omega naught plus phi. Here a is my amplitude, omega is my frequency and phi is my phase. What is the phase means? It is a delay. Simply we can say how much the one signal and another signal is delayed. That's all. So this is the simple idea behind this case, right? So we can also represent this signal in radians also. That radians is the omega naught. We can say omega naught is equal to 2 pi f naught. F naught is the frequency which is available in hertz. Next. So from this, based on the points we have discussed earlier, let us test our understanding level. So basically the question number 1 is, digital video is a 3-dimensional function which has 2 spatial and 1 temporal variable. So 2 spatial means it is an x and y axis and another one is the z axis that varies with respect to time. That's why we will call it as a temporal variable. Next one, the next question is a signal. A signal is a time variant or invariant. Most probably signal is a time varying quantity. It's not an invariant quantity. Invariant means mostly it will be relating to DC supply. So we are calling mostly the signal as a time variant. And then dash is also a signal, but it carries an unwanted information. Here the answer is noise. Noise is also a signal, please note it, but it is an unwanted signal. But basically for somebody a signal may be a noise, for somebody the same signal may be a wanted information. It will be like that. And then the one more final question is, most probably the continuous time signal is indicated with T. The function is, it is true or false. If a question is raised, it is T. Mostly we will represent a continuous time signal with a T. That's all. So the last question answer is true. Summary. So summary, here we have understood the fundamental building blocks of a signal, and I introduced the 4 basic signals. One is the impulse, unit, ramp, exponential and sinusoidal signals. Further we got some idea about the continuous and discrete versions of the same, and then finally we discussed how a continuous signal and it is used for some discontinuous analysis also. So with this I am just closing this presentation. Thank you.